In this video, I'll be taking the geometry that I created previously, subdividing it, and using height maps to displace the geometry before adding vertex color masks that I can then use with the material inside Unreal further on in the series. So next, I want to generate our cliffs. I want to subdivide this geometry, displace it using some height maps, and I want to do that to each one of these cliffs. As I said, I'm going to do that in tops. So for now, I'm just going to select one kind of cliff section to work on as I develop this next part of the tool. So let's just find a cliff section to use. I'm going to use this section here. So I'm just going to switch to the selection tool, double click on a selection, and come over to our geometry spreadsheet and just find that selection in our spreadsheet. There it is. And the class attribute on this section of geometry is 227. So let's add down a blast. Blast at class equals 227. And that will have blasted that section, and then so let's swap it to delete non-selected. Now we have just that cliff section. The first thing I want to do is to subdivide this geometry, because it's quite low res at the moment. So let's just subdivide it only a couple of times. It's not super high res, but it just kind of smooths it out and gives us a bit more geometry to work with. Now add an attribute from boundaries. And I'm just going to rename this group to boundary and the group type to be points. So that's created this group of just the points that are on the boundary of this geometry. I'm going to add a distance along geometry. And with this, I can specify a group of points, and then this node will measure the distance from those points along the geometry. Let's just change the attribute from distance to mask, because I already have a visualizer set up for that mask attribute, and then we can see that visualized in the viewport. So along the boundary, the mask will have a value of 0, and then as it moves further away, that value will increase. Now I'm adding an attribute remap, and the attribute I want to remap is mask. And currently the max input is 1, so I'm just seeing the values from 0 to 1, which are kind of very close to this boundary. So let's increase the max input to 4. Let's also change this to smooth. I'm also going to slightly blur that mask attribute as well. And the attribute we want to blur is mask. And then we'll set the blur iterations to 3, and that will subtly blur that mask. Next, I'm going to subdivide it even further. So let's do it another 2 times. So now we've subdivided quite a lot, so we can move on to now displacing this geometry. So I'm going to add a labs triplanar displace. Now let's select a height map to displace our geometry with. I highly recommend watching our introductory videos on Project Pegasus. There is a video on the project folder structure and how we organized our project files. We've been making use of Quixel Megascans. So this is our Megascans library, and you can see here I'm using rock jagged and then the unique ID. So if you want to use the same texture as me, if you search for this ID on Megascans, you'll find the same texture. And you can use these for free if you're using the Quixel library with Unreal. And we're going to grab the displacement. Let's turn off visualization And also let's switch off that wireframe. And you can see we've got it there, but it's kind of tiled very small. So let's increase this scale to 0.01. And then the displacement map, say 10. And then under advanced, I'm going to uncheck displace Y. So now it's no longer displaced in the Y axis, it's only being displaced outwards along X and Z. And then I'm going to check use displacement scale attribute, and we're going to use that mask attribute that we created along the borders. So now these edges will be flush with the landscape, whilst the cliff geometry will be kind of protruding out of it. And if I just say increase this to 15, you can see we're starting to get some intersection here, where the geometry is kind of displacing outwards into itself. So to fix that, after the subdivide, add a normal node. I'm going to set this to points. So this will now have created a normal attribute on the points rather than the vertices. Then I can use an attribute blur to blur that normal attribute. The attribute we want to blur is normal. And then let's increase this blur iterations. So I've increased it to 100. We still got some intersection, so let's say do it to 200. There we go, that's now reduced that intersection quite a lot. Let's just reduce that displacement amount down a little bit. Now, this is okay. We've got some nice looking cliff shapes, but we've only got one displacement map, and I think we're going to notice that tiling when we play it uniformly across the entire, across every single bit of geometry. So I want to mix in a second displacement map to kind of break up that tiling. Let's duplicate this triplanar node by holding Alt and dragging to create a copy, and then load in a second displacement map. This one's going to call Rock Cliffs. And this is what I'm grabbing. Again, you can find this Max and Quixel texture by using this, by searching for this unique ID. Grab the displacement. And there we go. We've now got two cliffs with two different displacement maps displacing the geometry. And now I want to blend these two together. I'm going to do that using a point of op. I'm going to have my first triplanar displacement on the first input and the second triplanar displacement on the second input. And then what I'm going to do is have a third input, which is a mask. So from the attribute blur, let's add an attribute noise. So this is currently creating a color attribute. Let's just set this to float and increase this element size. Increase it to say 25. Let's remap this. I'm going to change this to smooth. And I don't need a mask that's quite this detailed, so let's reduce this. Let's reduce the octaves to 2. And then bring down the roughness. Let's change this to an attribute called blend. Again, I could add another visualization here. To visualize that blend attribute in the viewport. Let's add this to the third input. And double click our point op to dive inside. I'm going to use this here. I'm actually going to use some bind nodes. So let's type in bind. And the first one I want is position. So this is importing the position attribute on the first input of my point VOP. And I want to mix that with the point position on my second input. I can import that by typing in op input 1 underscore p. And this will import the position attribute that is on the second input, because the first input has an index of 0 and the second has an index of 1. Let's add that to the second input on my mix, and that is a 3 float vector. And I'm mixing these together using that blend attribute, which is on the third input. So let's type op input 2 underscore blend and attach that to the bias. And if we attach this to the position and take a look at our point VOP, now it might look like nothing has happened at first, but if we swap between the two triplanar displace and the point VOP, you'll see something is changing. The geometry is being displaced, but the normals haven't been recalculated. So if we add a normal node, there we go. Now the normals have updated, and we can see we're blending together these two positions on this geometry. Let's also add a bind export and export that blend attribute. So there we go. Now you can see this is the areas that get blending together. Let's disable that visualization. So this has helped break up any potential tiling, but I want to take it a bit further. Currently we have some nice looking cliff shapes. For instance, we have this nice kind of overhang, this horizontal line. But when we view this across the whole landscape, we'll see this line consistently running from one end of the landscape to the other, running from one piece of cliff section right across to another. And that's going to look quite uniform and rigid. So I want to break that up a bit more, so it kind of looks like it's kind of maybe folding and buckling like geological layers. So to do that, what I'm going to do, before we apply the triplanar displacement, is create some kind of vertical offset. So we can do that. Let's do that up here before the subdivide. Add an attribute noise. And change the attribute name from color to P for position. Let's scale up this element size. Say really big, 500. And increase its amplitude. Let's set this to 0 centered. And this might start to look a bit weird, but bear with me. Say 100. And I only want to displace these points in the Y direction. So now if I can see, these are only displacing them in the Y directions. These just kind of lifting up these points, but they've got a bit of more of a warp to them. So now when we apply our displacement, our geometry's been warped in the Y direction, projected our displacement using the triplanar displacement. So now let's restore that Y position. So after the subdivide, let's add a null. Let's name this blend height maps. We're going to add another point VOP and call this restore Y position. Now the first input will be our geometry here, and the second input will be our geometry before we warped it. Add that on the second input and dive inside. And now let's add a bind and bring in the point position from our first input. Now let's bring in the point position from our second input. So op input 1 underscore p. And let's take this point position of our first input and add a vector to float. And let's duplicate that and do this, add the same to our second input. Oops, we need to set this op1 input point position to a vector. Now we want to then add a float to vector. So I want to take the x and the z from our first input, but take the y position from our second input. So here we have the position from our first input, which is our warped geometry. We want to keep the x and the z position, but restore the y position before our geometry was warped. Let's add this to position, and now you can see we've got our geometry restored to its previous position, but we've kept that displacement, and it's kind of given this kind of warped look. And we can tone down this warping by just reducing the amplitude on the attribute noise. So if we reduce this amplitude here to say 50, there we haven't got quite so much warping as we had before. And we can continue to dial in this warping. Let's try 75. Yeah, that kind of works. Let's keep it at 75. And if I disable and re-enable this attribute noise, you can see the effect it's having on the landscape. Alright, now we've got quite a lot of geometry here. Some of it's is here to add the kind of nice detail from our displacement. We've got some very smooth areas where we probably don't need this quite so much geometry. So let's do a poly reduction. Let's add a poly reduce. Set this to 80%. Now this has reduced the geometry just a little bit, but I want to bias the poly reduction so we reduce more polygons along the perimeter where it meets the landscape. So in our poly reduce, let's come down, check this retain density by attribute, and the attribute we're using is mask. Let's zoom in a bit. Then we can use this weight parameter to change how much this mask attribute influences the density retention. I'm going to set this to 6. There we go, we're kind of now reducing the poly count along these edges, but keeping it internally where we have the detail. And if you want to reduce the poly count further, you can reduce this percentage. So now I want to create some masks that I can use with my material inside of Unreal. So I'm going to generate a curvature mask and an ambient occlusion mask. So after the poly reduce, add a labs measure curvature. If I just disable lighting to make that clear, there you can see we've got a color attribute, and this node is generating a convexity and concavity mask and storing those in the red and green channel of the color attribute. So if we come to the geometry spreadsheet, we can see we've got this color attribute here, and we've got values in the red channel and values in the green channel, but currently nothing is stored in the blue channel. And I'm going to add the ambient occlusion mask to this blue channel. So after this node, I'm going to add a mask by ambient occlusion. Currently can't see anything, but we can see here it's creating a mask attribute. So let's just switch on the visualizers. And I already have a mask visualizer here because I've been using this attribute previously. And in the viewport, you can see we've got that ambient occlusion mask. I'm going to turn the blur iterations down to 10. And then remap combined mask and just make that ambient occlusion mask pop a little bit more. Now I want to store this mask attribute in the blue channel of the color attribute. Let's just disable that visualizer for that mask and add an attribute wrangle. And type @cd, which is the color attribute. And I want to use the blue channel. That is equal to @mask, which is the mask attribute. And then end that with a semicolon. And it might not be terribly clear, so just to make that stand out, @cd equals 0. And there you can see we've got that ambient occlusion mask now stored in the blue channel. Let's just delete that previous line. And now I have that convexity, concavity, and ambient occlusion stored as a color attribute on the points. And when we import this into Unreal, this will be imported as a vertex color. So I can use that within my material. Just make some slight adjustments. I'm going to increase the blur amount on the convexity and concavity to 5. Just to smooth them out a little bit. And then I'm going to add a normal node just to correct the normals after our polyreduce. And I'm going to turn that up to 180. And the last thing I'm going to add is an attribute delete. And I'm going to check delete non-selected and then just specify the attributes I want to keep. So that's color, normal, and class. So that will remove any unnecessary attributes that I don't need to export. Finally, add the output. And so this concludes the second digital asset that we're going to create. So I'm just going to select everything from the subdivide all the way down to the output and convert it to a subnet. Let's just hit L to lay out these nodes. Let me just color this blast node. Now we have the beginnings of 2 digital assets, because the first one is the high field extractor glyphs, and the second one is high field glyph generator. In the next video, I will be switching over to Unreal, where I will be creating the material that I want to use on these glyphs when they're imported into Unreal.